Okay, let's start off with arithmetic progression. Now, let's take for example, 2, 5, 8, 11, 14. Okay, now, as I say, the first thing you have to do is to determine whether is it a GP geometry progression. So what you have to do is take one number, divide by the previous. I got 2.5. If I take 8 over 5, I got 1.6. You do not need to try the third division. Why? Because the first and two are already different. So this is definitely not GP. Okay. Now then we go straight to AP. Okay. AP, basically the principle is very simple. Just take this minus this, you get a 3. Take this minus 3, you got 3. You take this minus 3, you got 3. Take this minus, you got 3. Okay. Now the first row of different is already a constant. Okay, so in that case, the end term is very straightforward. Equal to a plus d n minus 1, whereby a is the first term. What is the first term in a given sequence, which is 2? Okay, so you just put a 2 here, plus d. D is the constant. Okay, this is the first difference which you already obtained a constant. Therefore, you use this formula. So d in this case is 3. Okay, simplifying this is 2 plus 3n minus 3, which give you 3n minus 1. Okay, now this is example 1. Let's try example 2. Ten, 6, 2, minus 2, minus 6. Now, using the same rules, this minus this, you got a minus 4. 2 minus 6, you got a minus 4. Minus 2, minus 2 minus 2 again, you got a minus 4. Minus 6 minus 2, you got a minus 4. Okay, so the first row of different is already a constant. Therefore, the end term using the same formula again, a plus d n minus 1. Okay, a is the first term, which is 10. D is the first difference, which is already a constant. So this is minus 4. So n minus 1. So simplify the whole thing is actually 14 minus 4n. Okay, that's it. Now, then we have another set also under AP. Okay, give you an example. 2, 5, 10, 17, and 26. Okay, now let's take the difference. 3, this difference is 5, this 7, this 9. Now, do you get the first set of difference? Do you get a constant? No, it's not a constant. So let's go to the second row of difference. This minus this, you got 2. This minus this, you got 2. This minus this, you got 2. Okay. Oh, therefore, the second row of difference, I already got a constant. So I can use the other formula, the end term. equal to a plus d n minus 1 plus c over 2 n minus 1 n minus 2. Okay, now let's substitute the a, d, and c inside. A, same as this, is the first term in the given sequence, which is 2. Now, what is d? In this case, where the second row of difference is constant, the d is not a constant. D is actually the first term in the first row of difference, which is 3. Okay? Compare with this, okay, where the first row of difference already a constant, the d is actually the constant. But when you have the second row of difference, which become constant, then d is not 2. Okay? The d is the 3, the first term in the first row of difference. Now then, what is c? C in this case is the constant, is 2 over 2. Expand this, you got nx, n squared minus 3n plus 2. Okay, now let's expand this. 2 plus 3n minus 3, this cancel, become plus n squared minus 3n plus 2. Okay, now this and this cancel off, n squared. So 2 plus 2, 4 minus 3 is n squared plus 1. Okay, now one more. 10, 7, 2 minus 5 minus 14. Okay, take this minus this, you got a minus 3. Take this, you got minus 5. Take this minus this, you got minus 7. Take this minus, you got minus 9. Okay, now this is not a constant yet. Let's minus again. This minus this, you got a minus 2. This minus this, you got a minus 2. This minus this, you got minus 2. Okay, therefore the second row of difference has become a constant. Therefore you must use this one. Okay, so the n term, a is the first term in the given sequence, which is 10, plus d is the first term in the first row of difference, okay, which is minus 3. Then n minus 1. C is the difference. Is the constant, which is minus 2 over 2. And then is n squared minus 3n plus 2. Okay, let's simplify the whole thing. 10 minus 3n plus 3 minus n squared plus 3n minus 2. Now, let's put the n squared in front, minus n squared. This is plus 3n, minus 3n plus 3n cancel off. 10 plus 3 is 13. 13 minus 2 become 11, so it's plus 11. That's it. Okay, this is for first set of difference become constant. You use this formula. When your second set of difference then only become constant, you use this formula. Okay. In the next video, I will explain using the simultaneous method to solve it. Okay.